All right, geometry, here we go. We're starting section 3 off, and section 3 starts talking about a new set of shapes, okay? And today we're going to be looking at polygons, and we're going to work on finding area and perimeter and collecting data on that. So if you have your book open to 831, you can have that open, or I can just read it to you right now. So in number 890, the problem that we're on, it says, in order to predict the area and perimeter of a polygon with infinitely many sides, your team is going to work with other teams to generate data in order to find a pattern. So what we're going to do here, it says, for each polygon, find the area and perimeter if the radius is 1, as shown in the diagram of the regular pentagon above. So in the book, it shows you a diagram of a pentagon with a radius of 1. Let's actually draw that in our notes off to the side here. So if you have your book open, you can see what I'm talking about, but it's just a pentagon. So let's just draw a pentagon in here, a regular pentagon. So try your best to draw a regular pentagon. So a 5-sided shape with 5 equal sides. So it's something like that. That's not my best regular pentagon, but there you go. So, and now if we look here, it gives you the 3 vocab words that we're dealing with this chapter. So a radius goes from the center of your polygon to one of the vertices. So these are your vertices, the corners, okay? From the center to a corner, that's a radius. The apothem, we've talked about that a bit. That goes from the center perpendicular to one of your sides. So let's add that perpendicular marking there. And then a side length is just a side length, okay? So for all of these shapes, we're going to find all of this data. We're going to find the apothem, the side length, the perimeter, and area, and take a look at the numbers and see what happens as we approach an infinite number of sides. So a polygon with infinite sides, and we're going to see if we can predict what the area and perimeter would be if you had a radius of 1. So for all of these, we are going to assume that the radius, going from the center to the corner, is 1. Okay, we're going to say that it's 1. That way we can, have an accurate table of data where every radius is 1. Okay, so let's review. So we know what perimeter is. That's just all your sides added up, and we know what area is. Okay. Our formula for the area of a regular polygon, let's write that down off to the side here. So area, let me zoom in a little bit here. So area of regular polygons hopefully some of you know this, but if not, that's okay. Area equals 1/2 S A-N, and remember when I put an S, I like to put a little hook at the end. That way it doesn't look like a 5. You can choose to do that if you want. That way it doesn't look like a 5. Okay. So this is our formula for the area of regular polygons. Remember, S stands for side length. Okay, so that's just a side length. A stands for the apothem. So that's this side, or that side right there, going from the center to perpendicular to a side. That's the apothem. And then N is your number of sides. Okay, those are the 3 things you need to find the area of a regular polygon. So that's your formula. Okay, we talked about why that was a while back. Basically what you're doing is you're finding the area of one of these triangles and then multiplying it by the number of sides. So that's why it's 1/2 of your side length times your apothem. That's the area of that triangle, times your number of sides. That'll tell you the area of the entire polygon. Okay, so that's what we're going to do with all of these shapes. So we're going to start with the equilateral triangle. We'll work through these first few examples together, and then I'm going to let you guys work on the rest, and I'll just fill in the table, and you guys will check your answers. Okay, so let's flip over to the back of your paper. So flip on the back, and we have all this empty space. Start in the top left, and let's start with 3 sides. And we're going to work our way up to infinity. Okay, so if we have a 3-sided shape, and these are all regular polygons, so if we make a 3-sided regular polygon, that's an equilateral triangle. So that's why it says equilateral triangle on the back. Now we're going to say the radius is 1. So from the center to a corner, that distance is going to be 1. Okay, so mark that as 1. And now we need to find the area of this. Well, the way that we're going to do that is we need to find our apothem. So that's going to be this side right here. So I'm going to label that A. And we need to find our side length. Okay, so we need to find this entire length, S. And to do that, we need to first find B, which is just going to be half that distance. Okay, so for a key, let's make a little key off to the side here. So on this page, A is going to stand for apothem. Okay, A stands for apothem, and B is going to stand for half of the side length. Okay, those are the two letters we're going to use. That'll be our key. We'll keep that up there. Okay, so A is for apothem, B is for half the side length. Okay, now that we know that, we're gonna try and find A and B using this triangle here. So let's draw that triangle a little bit bigger. So just this triangle. We know this is 1, and this is A, and this is B, and it's a right triangle. So if we can find these two angles, then we can find this A and B using trig. Okay, well, if you think about an equilateral triangle, hopefully you guys should know by now that these are all 60-degree angles, because in order for it to be a equilateral, all three angles have to be the same, and they have to add up to 180, so they all have to be 60, okay? So these three angles are 60, but now this angle is getting cut in half. So half of 60 means that this angle down here is going to be 30. Okay, so that's 30. And then that means this has to be 60 up here. So this is a 30, 60, 90 right triangle, which means we can use our shortcut. So if you look up at the wall, you can use that shortcut. And if we look at our hypotenuse, it's 1. So that's the 2x part. So here, I'll just draw a quick picture of that. So there's our special right triangle. So the 2x part is 1. So that means x is going to be 1/2. So I know that A is going to be 0.5. Didn't even have to use any trig here. Okay, it's just 0.5. And then B is going to be x times square root 3. Well, x is 0.5, so B is going to be 0.5 square root 3. Okay. All right, so we know those two things. So the other thing is now we can find our side length. Our side length is 2 of these B values, because B is half of that total side length. So let's just go ahead and find S. If we take S, or if we take 2 times this, 2 times 0.5, that just cancels out. So we're just going to be left with the square root 3. So the two numbers we need are A is 0.5 and S is the square root 3. Okay, so let's flip that back over. Let's fill that in. Our apothem was A, that was 0.5. And our side length we just found was the square root 3. Let's type that into our calculators to see what we get. So you should all have your calculators out. Let's type in the square root of 3. And we get 1.73 approximately. Okay, so that's our side length. Now if I want to find the perimeter of that triangle, I got to take my side length times 3. I'm going to keep this number in my calculator, that way I'm not rounding. I'm just going to take that times 3. Let's see what we get. Okay, so there's our perimeter. If we added up those three sides, we get 5.19. Or if we round that 9 up, that'd technically be 5.20 if we round that up. So 5.20. And then the area of that is we need to use our formula. So 1/2 SAN. Okay. So we know our side length is the square root 3. So let's say I'm going to type that in first. So I got the square root 3 is that number. Okay. I want half of that. So let's divide that by 2. Okay. So there's that. And I need to take that times my apothem, which our apothem is 0.5. So let's take that number times 0.5. And then we need that times our number of sides, and there's 3 sides. So take that times 3. Okay, so there's our area for the first one. It's 1.30 is what we'll put in. Okay, so we got our area and perimeter for the first shape, and we're going to see if we can find a pattern as we increase the sides. Okay, so now let's try doing the square. Let's do that one together as well. So let's flip that back over. So we just did 3 sides. Now let's go ahead and try 4 sides out. Okay, and a 4-sided regular polygon, that's just a square. So if we want to draw a square, okay, and our radius is going to be 1. So from the center to this side, that radius is 1. Okay, let's label up A and B. So here's A, here's B, and we need to find S as well. Okay, so that's going to be S. All right, so now let's draw this triangle. I'm going to draw it off to the side a little bit, right over here. So if I draw that, if you think about this, this is a square, so you know all 4 angles are all right angles, okay, in order to add up to 360, right? Eventually, as we get bigger and bigger, we're going to have to be using our interior angle for the regular polygon formula. We'll have to start using this, but we know that for a triangle and a square, we know those angles. Okay, so this is 90, but if we split it in half, it bisects, this radius bisects that angle, and half of 90 is going to be 45. So we know those are 45. So this is a 45, 45, 90, and we know our hypotenuse is 1. Okay, so now if we go backwards to find our apothem, if we're thinking about our special right triangle, okay, if you remember that, so it goes x, x, and then x square root 2. So now if we go backwards, we have to divide 1 by the square root of 2. Okay, and I'm just going to tell you guys on this one, that simplifies to the square root 2 over 2. Okay, so that's going to be our apothem, and also that's the same thing as your b value as well. So this is A, and this is B. Okay, so now that we have A and B, now we can find our side length. So our side length is going to be 2 times this. So let's write that down. So S is 2 times the square root 2 over 2. And for this part, the 2 divided by 2, that just cancels out. Okay, so we're just left with the square root 2. Okay, so we got the 2 things we need. We got our side length, and we got our apothem. Okay, so let's flip that back over, and we're going to write those 2 numbers down for the apothem and the side length. Okay, so if we flip back over, our apothem was the square root of 2 divided by 2, and our side length was the square root of 2. And if we type that in our calculators, make sure you guys know how to type this in, we get 1.41. Okay. All right, so for our perimeter, we're going to take that number, our side length, since there's 4 sides, we're going to take that times 4. So that's our perimeter. We get 5.66 if we round up. And now if we want to do the area, we have to do our formula here. So 1/2 of our side length times the apothem times your number of sides. Okay. So let's do this one step at a time here. So we need 1/2 of our side length, which is square root of 2. So if we take the square root of 2, and we want half of that, so let's divide that by 2. Okay, so we get that. We have to take that times the apothem. Okay, if we multiply that times our apothem, that's the square root of 2 over 2. So I'm going to take this times the square root of 2, and then divided by 2, because it's the square root of 2 over 2. And then I need to take that times our number of sides, which is 4. So take that times 4, and it works out nicely. Everything cancels out nicely, and we get 2. Okay, there we go. All right, so now we're still watching for a pattern as this gets bigger and bigger. Okay, let's try out let's do pentagon and hexagon. Okay, let's keep going here. All right, so now we're going to move on to 5 sides. Now 5 sides, it gets a little bit trickier. So now if we have a pentagon, and you can try drawing it if you want. Okay, so there's a pentagon with a radius of 1. Now we need to find our apothem and our b value and our side length for this one. Okay, now for this one, this is what we're going to do for the rest of the shapes. Because we don't know exactly what the angle is unless you have it memorized, you have to use your interior angle formula. Okay, so you have to use this formula to find each of your interior angles. Okay, so we're going to plug in, so 180 times our number of sides minus 2 divided by our number of sides. We're going to plug in 5 for n. So let's do that for a pentagon. So if you just do 5 minus 2 in your head, that's 3. So we're going to do 3 times 180, 540, and then we want to divide that by 5. And we get 108. Okay, so that is each of our interior angles are 108 degrees on here. Okay, but now when we draw our triangle, we have that radius is bisecting this angle right here. So we don't want 108, we want half of that. So half of 108 is going to be 54 degrees. Okay, so now we have that. And now we can do some trig, and this is what we're going to do for pretty much the rest of the problems. So when I want to find, and I know my hypotenuse is 1, if I want to find A, that's my opposite side, and I'm given my hypotenuse. So opposite and hypotenuse, that's going to be sine. So I want to do sine of 54, and that's going to be equal to A over 1, or just A. So all I have to do to find A is I just have to type in sine of 54. So let's do that. So let's go to our calculators. Let's type in sine of 54, and we get 0.81 approximately. Okay, and I'm gonna do a fancy thing here. I'm gonna store this as A in my calculator. I'm gonna hit the store button, and I'm gonna store it as A. Okay, so now I have that number stored. Okay. Okay, and then I want to find B as well. So now let's find B. B is the adjacent side, and I know my hypotenuse, so I'm going to do cosine. So if I do cosine of 54, that's going to be equal to adjacent over hypotenuse, so B over 1, or just B. Okay, so if I want to find B, I just type in cosine of 54. Let's type that in. We get 0.59. And I'm going to store this as B. So store, and then I want to store it as B. And there we go. So now that's in my calculator. So I have that in here now. Okay, so let's flip this up back over to the front. And now we have those two numbers. So our apothem was approximately, it was 0.81. And then our side length was our B value. So if I want to call back that number, I go to second, and then recall is what that RCL stands for. Okay, and I want the B value, and I want to take that times 2 to get my side length. So take that times 2, because remember the B value is half the side length. So you get around, it's approximately 1.18. Okay. So first thing I'm going to do with that is I'm going to multiply that by my number of sides, which is, it's a pentagon, so I want to take that times 5 to get my perimeter. So for the perimeter, we get around 5.88 for the perimeter. Okay, still not really noticing a pattern yet. We'll get there. Okay, and then the area is going to be our formula here. So 1/2 of our side length. So let's get our side length back here. Okay, so there's our side length. And we want half of that, so divide that by 2. Okay, so we get 0.58, okay? We want to take that times our apothem. And so I want to take that times the A value in my calculator. So I'm going to say times, and I want to get my A value. So second, and then recall and I want my A value, okay, and I'm multiplying by that, so I get this number. Okay, and then I want to multiply by the number of sides, which is 5. So take that times 5. And so the reason I'm using the recall button is because now I didn't round anything there. Otherwise, you could just go back and type in sine and cosine of those numbers, okay? But I didn't round anything by using that recall button. So it's 2.38 approximately. Okay, next, I want you guys to go ahead and try the hexagon. Okay, try that out. So pause the video. You guys try out the hexagon. Okay, take a couple minutes, try that out, and then come back when you're done. All right, so for the hexagon, you're trying out 6 sides. So with this one, I'm not going to draw the shape every single time. I'm just going to draw the little triangle here because that's all we need. Okay, so if I draw that little triangle, so there's my radius of 1. I got A, I got B. If I want to know the interior angle of a hexagon, I'd want to type that into my formula, but if you type that in, you should just get 120, and then if you split that in half, that's 60 degrees for a hexagon. Okay, so again, I'm drawing that interior triangle. I'm just drawing that half triangle there. Okay, so that's what we got. We got 60, and this is a special right triangle. So what you should have gotten for your A value is the square root of 3 over 2. And for your B value, you should have gotten 0.5. Okay. Or I guess this is the same thing as 0.5 times the square root of 2. Or square root of 3. Okay. So if we go back to the front, our values that we should have. So for your apothem, you should have approximately 0.87. For your side length, you should have 1, because that was 2 times your B value, which your B value is 0.5. And then your perimeter is just 6, 1 times 6 sides. And then your area, you should have gotten 2.60. Okay. All right, next, octagon. I want you guys to pause the video, try out octagon, and then unpause when you're done. All right, so for 8 sides, if we draw that half triangle of the octagon, when you type that into your calculator, you should get 135 as your angle, okay? But then you cut that in half because that radius again cuts it in half, and you get 67.5. So this angle right here is 67.5. Now you can find A and B. Now this one you want to go back to your sine of 67.5 is going to be A, and cosine of 67.5, that's going to be B. Okay, so if you type those in, A is approximately, what did we get for that? For the octagon, it's around 0.92. And then for the B value, it's approximately 0.38. Okay, 0.38 for your B value. Okay. So then if you want to find your side length, you want to take that times 2. So, and then on the back, let's go back to the front. Let's fill in our numbers here. So for our octagon, we've got approximately 0.92 for that. And then for our side length, it was around 0.77. Take that times 8 for your perimeter, and that's 6.12. And then if you plug those numbers in to here, you should get around, it's 2.83. Okay, so again, if you do 1/2 of your side length times your apothem times your number of sides. And if you want, you can use the rounded numbers, and you can see how close we'll get here. If we do 1/2, so I'm just going to type in 0.5 times our side length. times our apothem times our number of sides, which in this case it's an octagon, so 8. You can see we get pretty close. Okay, we get around 2.83. So you can use the rounded numbers. That's fine. Okay, you don't have to do all the storing stuff. Okay. All right, go ahead and try a nonagon. Pause the video here. Try that one out. See what you get. All right, so for 9 sides, the angle that we get down here, it was 140, and then you divide by 2 and you get 70. So for A and B, you want to do sine of 70 and cosine of 70 for B. And let's just see what those numbers are. So for sine of 70, you should have gotten around 0.94. And our B value, cosine of 70, you should have gotten 0.34. Okay, so if you take that times 2, that'll be our side length. So there's our side length. Okay. All right, so let's go back to the front. So for our nonagon, the apothem, what was the number that we said? It was around 0.94. Our side length, we got 0.68. Take that times 9 for your perimeter and you get 6.16. And then your area, if you plug everything into your formula here, and again, you can just use these numbers, guys. So use your apothem, use your side length, number of sides is 9. Take that times a half, take those 3 numbers, times them together, times a half, and you should get around 2.89. All right, for these last 6, what I want you guys to do, assign groups. So there should be 6 groups. I want you guys to assign your groups A, B, and C. And if you're group A, you guys get to do, and since there's 6 groups, there's going to be 2 group A's. So those of you that are group A, you're going to be doing the decagon and the sextagon. Group B, there's going to be 2 group B's. You guys are doing the 15gon and the 90gon. And then finally, group C, you guys are doing the 30gon and the 180gon. Okay, so pause this video here. Take some time, do those 6. Okay, each group should be doing 2. Okay, get your numbers, and then we'll regroup when you're done. Okay, and we'll see what we got. All right, so pause the video here. You guys go ahead and do that, and then we'll regroup. All right, okay, so hopefully it went well. Let's take a look at the numbers that we should have for those last ones there. If we take a look here. All right, the numbers from the decagon, you should have 0.95 for your apothem, 0.62 for your side length, 6.18 for your perimeter, and 2.94 for the area. Okay. Then for your 15gon, you should have 0.98, 0.42, 6.24, and 3.05. Okay, then for your 30gon group C, 0.99, 0.21, 6.27, and 3.12. And then you guys can go ahead and write down the rest for the 60gon, 180gon, and so on. All right. Okay. Before we move on, I want you guys to answer, so make sure you have that all written, so pause the video if you need to. I want you guys to go ahead and answer the 3 questions at the bottom of the page. Okay, so answer these 3 questions, pause the video here, and then we'll go through these 3 questions as a whole group. Okay, so pause the video, go ahead and answer those. All right, so if we take a look at letter A, it says, what do you predict the area will be for a regular polygon with infinitely many sides? So if we keep increasing the number of sides, the area of a regular polygon with infinitely many sides, if your radius is 1, we would probably predict it to be 3.14, right? Which is what your area was getting closer and closer to here. Okay, and then what do you think your perimeter would be? Perimeter would probably be around 6.28 because that's what you should have in your numbers here. Okay, we can see it keeps getting closer and closer to 6.28. Okay. Okay, now what does this mean with a polygon with infinite sides? What is another name for a regular polygon with infinitely many sides? I'm sure a lot of you would be shouting at the screen right now. It's a circle. Okay, that's a polygon with infinitely many sides. It's a circle. And what is the significance of the number 3.14? That is the number pi. Okay, you guys know that. You've heard about pi from the past. Okay, spelled pi for pi. Okay, that is 3.14 approximately. Okay. So what does this mean? Well, basically it's giving us the ratio. You guys have just derived pi by finding the area of a bunch of these regular polygons. Okay. So what that means is if we had a circle, let's draw a circle. That's a terrible circle, but you get the point. If you had a circle with a radius of 1, that means your area would be pi. You would take your radius, okay, and you would do something with it, and then you take it times 3.14, and that would be your area. And then your perimeter is double that. So in the next lesson tomorrow, we're going to put this all together and figure out what exactly is going on here and figure out our formulas for the area and perimeter for a circle. Okay, but basically this lesson has just kind of helped you discover where pi comes from. Okay, this is where it comes from. One of the ways to prove pi. Okay. All right. Okay. Sorry I couldn't be here for this lesson, guys. I know this is kind of one where I would love to be there in person, but hopefully it went well. Make sure you guys are still working on your homework, getting those turned in. I'm going to be gone for another week, so keep working hard, getting your stuff done. There is going to be a test on Friday over this chapter. Okay, so make sure you guys are still working hard. Email me with any questions. I'll try to get back to you on my email as quick as I can. Okay, so send those in, keep working hard, and keep it up. You guys are awesome.